Welcome everyone to this latest Zero Carbon Mine webinar. This time we're talking to Clayton Franklin's giving you a bit of presentation on their sort of 100-ton electric truck that they've developed. So yeah, I'll hand over in a sec, but this group and these webinars are about just facilitating discussion around electrifying and decarbonising the mine industry. So it's sort of a lot of open discussion. Bring whatever you want to the group. And I'm sure Clayton will be open to it, but if you've got any questions as we go along, just raise your hand and we'll see if we can answer them. All right, so I'll flick it over to you, Clayton, if you want to share whatever, if you've got a presentation or whatever.
Thanks very much, Brett. I'll just share this one here. Righto, so should see some slides there. How's that, everyone? Can you see it?
Yep, I got that.
Rightio, so as Brett said, Clayton Franklin, Chief Engineer and founder of Electric Power Conversions Australia. We'll move on. This is where I started. So as a young fella, grew up on the farm, organic banana farm in far north Queensland. We're always fixing old machinery. The old man wouldn't spend a buck, so we always had this second-hand gear that we had to repair. That tractor there's been repaired or rebuilt 3 times. This is the first electrification I did, which was the farm's 4-wheeler. That's about 27 years ago. Lead-acid batteries, a motor controller, and we ripped out the petrol motor and put in an electric one. Still runs today, and we run it off the solar, so certainly zero emissions there. In 2006, I was the bushlight engineer, light life in the bush. We put in 140 renewable systems into the top end of Australia. We won the Engineering Excellence Award. It's close to my heart, that one, because I'm part Aboriginal. My mum is from Wannamara in Cloncurry, Queensland. I also hold patents on the Fortescue truck. That's the Sonic project. That's a hydrogen electric truck. I'm the patent holder for that. And also there's 3 patents on the truck that I'm about to show you now. So why are we doing all this? It's all for 30% reduction by 2030. And then obviously mining is a hard to abate industry. So, 2050 net zero, or we can call it real zero if we use Twiggy's terminology. Where did I start? I started in November's when we pushed the button on this build for this truck. 5 months later, we're at the Electric Mine conference. But yeah, we start everything in a digital twin. This is our model. It's in ANSYS. We built it here and we simulated it. We got an 8-hour runtime out of our simulation, but then when we built the truck, tested it in the field, we actually ended up with 10.5 hours. But we've gone back and validated this model. We started with a typical 777D, stripped it down in the blast shed there, put it through the paint shed, brought it back to the main bay. I should probably give a shout out to Ron Clark, private individual in Western Australia. Got about 200 bits of kit, mainly dozers and graders that are on hire to the miners in Western Australia. And he allows us to have a workshop and also the workforce. I bring the engineers, he brings everything else. And this is all done at his facility in Hazelmere, Perth. There's the team there. About half are trades and half are engineers. Software engineer, young Pat. Nick, electrical. Mo, mechanical. The old man. Me and the old man funded it. There's the old man next to me. I'm the guy with the dog. So between the two of us, he's mechanical. I'm electrical engineer. So he's a farming background, a fitter and turner. So he's pretty good on his hands. Gets it all done and certainly helped out. 78, probably should have retired, but you know what these old blokes are like. This is the engine that we took out, our C3508B. It's your typical powerhouse for the Caterpillar truck. It's quite a good motor. The 3000 series considered quite good. But when you look at the electric motor that we put in, you start to realise just how dated diesel is. Your efficiencies from electric are 3 times. This motor's actually 98% when you consider it with the inverter. Your diesel engine, if it's a standing engine, a stationary engine, you might get up around the 40%, but certainly for a mobile machine, 35 efficiency. You lose so much in heat, and there's so many moving parts. If you look at the moving parts in an electric motor, drive and non-drive and bearing, there's not really much to generate heat and lose efficiency. Horsepower, strangely, the electric is 1120 horsepower. So you take out something that's as big as that, it's only 1,000 horsepower. The other thing to note is, not shown in the picture, is an auxiliary motor. The auxiliary motor takes all the parasitic loads of the diesel engine. So the diesel engine, parasitic loads are your fan belt, your air con, your air compressor, and probably the big one is your transmission fluid pump, hydraulic pump for the rams, for the lift. All of that is probably, well, we've measured it, so it's about 80 horsepower. So, 1,000 isn't really 1,000, it's probably more like 900. And then you go and put in the electric motor, and you're driving all of that torque to your wheels. So you're going to move dirt, and we've proven this, move dirt up the hill quicker. Rev range is far better, and we've got more torque, so 5,200 Newton meters as opposed to 4,700. And the torque range, you get full torque at standstill, and it runs all the way to 2,000 RPM. A lot of redundancy in the electric motor. That's a dual stack, so you got redundancy. You can run with one motor. We've done that before. You can lose a battery, you can lose a chiller, you can lose an inverter, but on a diesel, you can't lose that alternator. You can't lose one of those coolers, the bottom cooler down the bottom. That's a transmission cooler. She don't run if you don't have that. You lose a turbo, you're down as well. So there's virtually no redundancy in the old diesel. Vibration and noise, we get blown away. Operators get into our truck and they're just really surprised by just how quiet it is. For once, they can actually talk in the cab, and there is no or very little vibration. Emissions, if you just run the numbers, typical numbers, 1260 tonne is what you're saving the environment. We're a company on our own, but we certainly get assistance from others. So I need to acknowledge EMJC, as I said, gives us the workshop and the trade labour. He also has heavy haulage. He moves our truck around. Our truck's been at the Crown Casino for the Electric Mine conference in May, where we debuted and the State Minister for Energy cut the ribbon. We then went up to Diggers and Dealers, and then now we'll be on Riverside Drive on the 2nd of December at the West Tech Fest. Ron moves that truck around for us at no cost. Yuan provide us with a charger. It's a custom DC charger, marries up to the truck. Austin built us the tray. It's a special tray just for our truck, redistributes weight, and Far Energy are working to get our truck to be driverless. This is our truck here. Now I'm going to stop sharing this slide because I'll play a video, which, and I'll move into just the, I might have to share a window here. I've got a video here that I want to play, so bear with me a minute. I'll just get that up here. Okay, just tell me if you can't see this. You won't be able to hear the video. Brett, just confirm for me you can't hear the noise, can you? No. All right. I'll just talk. That's the truck. That's the float. This is it coming into the mine. This is at Bakers Hill. So we've been driving around the workshop, then, the last 2 months we've taken it up to Bakers Hill. Barfield Brothers, private mine, it's a sand mine. They allow us to have the truck. This is what we found. So we found not 8 hours, but 10 hours, 37 minutes for a 75% depth of discharge. So, you can bring these batteries down to 90%, so we can get even longer run time, which we were blown away by. Same tray tip time, because it's the same mechanical components. And then you'll see the mine's behind us. We've taken over about half this mine, which was very kind of the boys. There's a Yuan charger there. That's a 10-foot C container. This is where the batteries sit from Zerotech. It's about 2 megawatt hours. That makes it the highest energy density in the world. There's the consumption up the incline. That's what we took it up. That's a small section of the mine that's just got a really steep ramp. So we can do as much as the diesel, if not more. That's our regen coming back down. And you'll see, not showing, but 22 kilowatt hours is what is stationary. So the machine's just sitting there. Right, I'll jump out of that now. And I'll go back to sharing slides. All right. So that was that video. Now move to the next slide. There we go. Okay. There's the truck there, 10-hour run time. It's 90% a Cat chassis. So the truck, people think it's built from the ground up. It's not. It's still got all the Caterpillar components. All we've taken out is the diesel engine and the torque converter. We get more power, charges 50 minutes. OPEX, significant reduction in operating. There's another slide actually, but instead of $102 an hour on your diesel, you're down to $22 an hour on your electric. That's based on Pilbara costs for the PPA, power purchase agreement. Retrofit, about 5 weeks if you got all the components. It's just like a slightly longer duration than changing out or, overhauling the engine at first life. First life for these machines is anywhere between 12 and 18,000 hours. Here's the CapEx. So if you handed me a truck, I'll hand it back full battery electric for less than what it costs you to go and buy a new diesel truck. Maintenance, well, we just don't have things to maintain, so there's no cost allocated to it. And then the running costs, as I described, 102 down to 22. Production time, so it's about 18 months if you order a new Caterpillar 777F, whereas electric, we can do it 8 months. It takes 4 months for the batteries to make their way from Ireland, and then we've got, that 4 to 5 weeks in the workshop. Total cost of ownership, this is probably the most important point if you're a miner out there listening. You're going to save 50% of your haulage costs. So if you're an Australian miner and you don't take any notice of this, others will jump in there, whoever's next to you on the mine there, and they'll be saving, a shit ton of money. It's not a couple of percent, it's very significant, the cost savings of these electric haul trucks. People do ask a lot about batteries. So we do use a lithium battery. It does hit its 80% asymptote. So what that means is if you start off at your 10-hour run time, by the time you hit your 4,000 cycles, you're going to be at 8-hour run time. The miner has just got to decide whether to repower, recycle, or keep going. What we find with most of our clients is they'll just take it to a lesser duty. They'll move it out of mine haulage and go to rehandle or a water cart and just keep that lower run time. You don't have to. 4,000 cycles is at 5.5 years if you run the truck 24/7. So you don't have to take your batteries out and repower the machine. You just change the duty. You do need to replace the batteries, but that is more around at year 14, 15, really when you've got a whole bunch of cells that have died, strings are now collapsing, and then now you've got to make the decision as to whether or not, take that battery pack off the bus, or bus, I mean the DC link, take it off, or whether to keep going. This is how we ideally would like to charge. Obviously, our trials we're using genset because it's simpler. But if you look at the energy consumed by a truck my size that's running 24/7 on a mine site, this is the size of the solar farm that you'll need. And then that's the size of the Yuan charger box. It's not all the charger. It's got stationary batteries in it as well. So you're basically trickle charging your stationary batteries, and then you're dumping into the truck. The interesting thing is that that charger can do many more than just one truck. So this truck pulls up, gets charged, but obviously it can just continually dump charge. And they size the batteries accordingly and the solar farm. Probably the best way to go, but yeah, certainly early trials are off the grid. But with the Yuan box, you're still trickle charging. So this is Q&A. I do have some more slides. But I am probably going to open the floor to discussions. There's some other stuff around batteries here, if they're interested in battery tests, and then the Yuan charger, our autonomous system, how we're making it driverless. Yeah, and that's about it. But I can talk to any other topic or what people want to hear. So I'll stop sharing and open the floor.
Thanks, Clayton. It was yeah, a lot of information there. I suppose we've already got a couple of questions, but if anyone else has got any questions they like answered, then yell out. I suppose we had one from Edward talking about the energy densities, impressive. Like what sort of chemistry in those batteries, NCA or?
Yeah, so we're using NMC. NMC gives you the highest energy density. So when we started out, look, the other trucks I've built in the past, I did drill rig as well. It was all LTO, but LTO's, like a brick, very heavy with not a lot of density. So yeah, we've gone for NMC. We're happy with the energy density. If you're going to ask probably the next question, are they as safe? No, that chemistry is not quite as safe, but when you've got all your other layers of protection on top of it, like a safety system with an emergency shutdown, you've got the BMS that'll shut itself down at 65 degrees, and then other layers of protection for thermal runaway. The chemistry doesn't really matter too much when you've got so many other layers of protection on top. But yeah.
I think we had another one about, I'll just read it out. What is it? Your autonomy difference in cold weather. Someone from out in Canada, I think it looks like in -25. Like how would it perform in different climates like that?
It'd be you'd have to park it in a shed. You'd have to put heating blankets on the batteries. The batteries don't want to go below 0 degrees. If you're running, obviously we're in Australia, so we run a chilling circuit, but the same chiller can be a heater. So you're all right when you're running, but then when you park up, you're going to have you're going to have all your coolant circuits freeze and go, and you'll have problems. So we don't have too much of that in Australia, but yeah, I'd say heating blanket and get it out of the, keep it above 0 degrees. Yeah, there's not much more you can do. Batteries want to be in that sweet spot between 0 and say 35 degrees. They don't want to get too hot and they don't want to be too cold. Yep.
That makes sense. So, well, your development, of this electric truck is it's happened pretty quick. Like, what brought that on? I'm curious, like, where that came from, and and pretty impressive how quickly you do seem to have pulled it together.
Yeah. So, as I said, background, I was the lead Fortescue engineer for the Sonic project. So we did a hydrogen electric truck, and really I had a lot of improvements in my mind that management weren't too interested around. At the time, Twiggy was just hell-bent on hydrogen, wasn't interested in full battery electric. I didn't see any future in hydrogen. Hydrogen might be all right in planes, but certainly not in mobile machines. So I just couldn't get that design out of my head, kept me up at night. And so then, come November, I'd already knew what components I wanted. So I just started ordering, and then I started to, do my detailed design. I think also there's a bit of a fallacy in the market that this is really, really difficult. And if you look at, say, Caterpillar, I mean, they have taken, what are they? They're probably at year 7. Early learner program has been going for many, many years. And if you ask anyone at Caterpillar, this is a really difficult thing to do. Komatsu think much the same. But, I'm an electrical engineer. It doesn't seem too complicated to me. Yes, it's got a bit of a control system that, is got some complexity around it. But if you've got a good engineering team and if you've got a workshop that know the diesel part of the truck, then yeah, I mean, we did our first one in less than 6 months. We actually had that machine running in 5 months. So yeah, and we've ironed out a hell of a lot of bugs. I think we can move a hell of a lot quicker than your Caterpillars and your Komatsus. I mean, Komatsu have hardly started the race, right? And yeah, I just think, yeah, we just get on with it. It's probably more around our culture and also just our ability. And yeah, okay.
I also had a question, Don, and like, I'm not sure if you mentioned at the start, but the progress with customers, like, I know it's probably still early days actually getting out there, but have you got any out, apart from your trial site, have you got any out operating on sites as yet? Or
Yeah, so we built that truck and we demonstrated that last month to the miners in Western Australia. And out of that, that actual truck will go to the Pilbara, convert to a water cart, go to the Pilbara. Two more need to be built and go up to the Pilbara. One is going to the goldfields and one will go to the southwest. So from a company perspective, we've done performance testing, which really allows me to see and my team to see how this truck performs in a true mine, a sand mine, which the sand mine's very close to what Alcoa do down there, or South 32 at Boddington, where it's shallow mining, it's alumina. It's not quite as deep a pit, obviously, as the super pit. And it's not quite as longer runs as what our iron ore miners experience. So we've done our performance testing. And then now we move on to the next phase, which is endurance testing. So put those trucks, Pilbara, Southwest, Goldfields, and then what that allows is for me to get many tens of thousands of hours. And then I can say with very much confidence, you know, this is the final design. Then we go into mass production because we have clients not just in Western Australia, but we have them all over the world, somewhat chomping at the bit to move into electrification and just waiting for us to, you know, finalise and finish our endurance testing and be comfortable to start sending kits.
yeah, no, fair enough. Because I thought, like, when you've some of the costs and other things, you know, yeah, until you've got, you know, that more robust testing, you know, you can have projections on what it's going to be, like, you know, your lower costs and all that. But yeah, it's,
Yeah.
because I could say, you know, what you know, your operating capital and all those numbers that you throw out there, that, you know, they're probably fairly reasonable, but yeah,
You've got to run that truck for long enough to sort out, you know, exactly what the maintenance is going to be, and then also the performance over a variety of different temperatures, you know, and different mining environments. Yeah, and just different mining duties as well. The impressive thing, or one thing to note, the old truck, 77 data points, the electric truck, 3,000 data points. So there's a lot of data that comes off that truck. And most of our clients allocate a full-time data analyst because it is an enormous amount that you can gather, you know, from the truck that's available. It's phenomenal. Yeah.
Another question from Ed on, like, on-grid applications. Would you still use a Yuan charger system? Like, what's
Yeah.
the max sort of charge sort of
Yeah.
rate?
Yeah, so as I said, it's custom built for my truck. So they have, depending on what the client wants, depends on how much stationary battery. But that box is either AC or DC. So it'll take an AC feed, 415. We charge it at the workshop. It's pretty unreal when you get a client out there and they say, "Oh shit, we thought we needed a new substation." I said, "No, mate, I just plug it into my workshop. She charges up and I dump the charge into my truck and drive it around." It's so, you know, you can take AC and then obviously DC as well. We'd like everyone to have a solar farm dedicated to their mining fleet, but you know, maybe that'll come in the future. That's the way of the future. The other thing about solar farms, we've got to get off the dependency of diesel. Zero emissions, yeah, and saving costs, yeah, but also people don't realise we've only got a week's worth of supply of diesel in the country. So if we go to war and we don't have that diesel supply, you can forget about mining. It'll all shut down. But if you decentralise your energy generation by having solar, wind and so forth up on the mines that aren't dependent on diesel, well, then you've got a chance, you know.
Fair enough. Yeah, definitely. Yeah, take control of your energy source rather than sort of, you know, having it out of control. Question from Andrew, like you mentioned electric drill rig, I think earlier on. I was curious what sort of rig that was, and did it get used for grade control or yeah?
Yeah, look, it was an Epiroc D65. It was a Fortescue drill rig that we converted there. No, it didn't get used. I think it just got used for a LinkedIn video, and then parked up, which is a bit of a shame when you put so much engineering effort into these things. We do have a couple of clients that are talking to us about drill rigs. Yeah, and you certainly can electrify drill rigs. They're pretty easy to electrify. One of the problems you have with trucks is putting batteries into that engine cavity, whereas a drill rig has a platform so you can stack as much as you like. So the actual conversion's pretty straightforward. Yep.
I had a question around like the correlation of your data from your simulation against the actual. I think you mentioned that your earlier simulation said 8 hours runtime, and you actually got 10 and a half. Like, I suppose it's how's that correlation looking like? You getting better at tweaking your model as you're going on?
Yeah, I think the frictional force had a problem there, and also our aerodynamics. So we had an issue there, so we had to sort of fix our model up for that. With our model as well, we've just been given we think we've got a green light with CSIRO. So we've got two things happening with our model. One is CSIRO is going to validate it in the near future, work with us. And the other thing is one of our clients is actually going to survey the entire mine. And then what they'll do is they'll get the equivalent rim pull chart. So when a mining engineer has decided on his truck fleet, he uses that rim pull chart. It gives you incline, various inclines, heavy, full or empty or in between. And then obviously you can see speed out of an incline and then which gear he's in. So that rim pull chart, if we reproduce that for electric, then we can get it into programs like Hall Sim. So we're doing those things as well. If we get into Hall Sim or MindMax, whatever, this client's using Hall Sim, so we get into Hall Sim. Then what that'll do is that'll allow miners to just go there and pull out of the library an EPCA truck. And then you can run as many simulations as you like. You can run up and down different inclines and declines and move bloody charges here, there, everywhere, and put one truck or 10 trucks, the whole fleet or whatever, knock yourself out. And that's really the key where we need to get to so that people get more educated and they can run all their different scenarios. Probably put consultants like yourself, Brett, maybe out of a job, but, it'll get it out there more. So that's another thing we're doing. Okay.
Yeah. A lot of it, is around education and I suppose having the robust data behind you, but then actually being able to show how it does perform in the real world. Another question around like, what other mining equipment do you see as easy opportunities for electrification? You're saying drills are probably not too hard, but anything else that you're either looking at or think would be easy to electrify?
Yeah, look, I think we're sort of driven by the market. So trucks is number one for our client base. Number two, drill rigs. The third one that we're seeing is loaders. Seems like there's a desire for loaders as well. I know BME do the smaller loader, but I'm talking around the 992, 993, 995. So the one where really you can just do 2 or 3 passes and you've loaded either a 777 or a 785. So those machines will be done. They're relatively easy. And they're good ones to do. They're a lot easier because they're duty cycle, so they run hard, then they pull back, run hard, then they pull back. And you're driving hydraulics, it's a relatively easier duty, and you've got plenty of room for your batteries. It's not complicated at all. But I see them. Graders, you would have seen an announcement. McLean Engineering with Fortescue doing 30 graders. That's good. Graders maybe further down the track. Dozers will be hard. vibration is difficult. Dozers are on tracks and they just smash all the time. So that'll be an interesting one. But, you know, again, they can be converted. It can all really be converted. It's just the desire for the miners and what order they want it done. Yeah.
And definitely getting plenty of questions coming through, so I'll just keep throwing them at you if you're happy with that.
Yep.
One from Ben, like, have you looked at capacitor battery blend, like short run of trolley assist on the ramp surface for fast charging capacitors?
Okay, we don't do anything that's not commercially available. So really, if you look at EPCA, we're sort of a system integrator. Yes, we have a product that we'll own and lease, certainly in the early phases, but then later on, people will buy the product. So I only use what's commercially available, so I don't look at anything that's too far out in the future in terms of battery technology. With trolley assist, if you're doing a large truck, so if you're doing above 200 tonne, then yes, you will need trolley assist. So 100 tonne, 150 tonne, you can get the energy density onto the truck. So you can do exactly what we're doing, which is what we've demonstrated. But if you want to do something larger, then you really need that trolley assist. And that's because you just can't get the energy density onto the truck. You know, Caterpillar are showing that with their dynamic energy transfer. Fortescue, actually, to be fair, Fortescue actually just buying those 240 tonne trucks that were released at Las Vegas, and they're not taking trolley assist. Twiggy's going to just run them they run for 2.5 hours, so he's going to run them for 2.5 hours and then charge them very quickly in 30 minutes with his MCS system. So slightly different philosophy. That's not what I would do. I think 2.5 hours is too short. We should be hitting 8, 10 or 12. And that's sort of where I see it. So, you know, that's my take on it. Hope that answers it.
Yep. And now, you know, the 100-tonne trucks, I suppose, folks at the moment, you're not, you know, like you're saying that those bigger trucks probably, you know, come with issues trying to get, you know, the batteries on board and all that. So you won't be looking at the bigger end until you get this one sort of sorted out in the market.
Yeah, stick with the 100, and then we've got orders for the 150 tonne, which is only a small step. And then just so people know, I'm sure they do, educated audience that we got here, under 200 tonne, depends on the OEM, but typically that's a mechanically driven truck. So it has a motor, torque converter, tail shaft into the gearbox and then the diff. Whereas if you have above that size, then they're AC electric. So AC electric, diesel engine onto an alternator into a chopper box, and then chop that up into the right waveform for your AC electric motors. So AC electric, really that size, they're a lot harder to get the energy density, but they lend themselves to trolley assist. But trolley assist is expensive. It's a capital intensive exercise. It also has limitations in the mines regs in Western Australia. So if you look at Reg 166A, you'll see that you have to keep personnel away from the danger zone. The danger zone being where that live exposed bus bar is, or overhead conductor. So there's complications around dynamic charging as well. Yeah.
Question, Don, around what the range of cost to retrofit a 100-tonne truck would be today, and what it could possibly get to when you have, you know, when you're doing bigger volumes of retrofits. Yeah, and whether how those costs would change, challenges change for bigger trucks. I think you covered a little bit about those challenges, but do you think the costs will come down as you're doing more of these trucks?
Yeah, there's two things that are going to happen. One is you're going to see energy density of batteries increase. So we've already seen that. If you look at what happened with solar, it's going to be similar for batteries. So batteries, lithium batteries, you're getting 20 to 25% year on energy density increase. So last night I was at a presentation and a fellow, he rips out old batteries out of these old cars, Nissan Leafs and so forth, and he puts in new batteries. He's got to put spacers in there, because his new battery not only has more energy density, but it's a hell of a lot smaller space. And we're seeing that, right? So we're going to see energy increase. So that'll be one thing. So you'll be able to physically put more capacity onto a truck, which will alleviate those issues with the larger trucks. And then the other thing is you're just going to see a reduction in price. So the Chinese, I don't buy Chinese batteries, but the Chinese, have seen or are stating that there's a significant reduction in cost. As the demand increases, you will see the cost of batteries come down. And just to put it in perspective, at the moment, EPCA retrofits diesel truck into battery electric for about the same price or less than what a new diesel would cost you. But, in, I would say 3 or 4 years, will be half that again. And that's because the batteries make up the major component of what we're installing. Yep.
All right. Covered most of the questions. So if anyone else has any questions out there, please, type them in or raise your hand if you want to yell out. Did have one from Lachlan around how much does operator behaviour impact the runtime of the trucks? Like, does fuel burn on diesel trucks? Is it similar?
Yeah. So diesel truck operator, flat to the floor, flogs the guts out of it, up he goes. With an electric truck, the throttle position is far more responsive. So throttle position actually drives an electric motor that sits in torque mode. You can have them in speed mode or torque mode. Obviously, we sit in torque mode. And what you find is you don't want to go flat out up the ramp. You don't need to do that. The reason for that is that the torque curve of diesel is that shape, parabolic, inverted, and 1750. So you're just changing gears around 1750. Whereas when you look at electric, it's up, flat, and down. So what does that mean for operator behavior? It means you can still get full torque, but not have full throttle. So you don't have to sit in that 1750 band and be messing around with your gears. You can, and we've been doing it on the mine, just throttle back. It still moves up the hill, slightly slower, but you still get full torque and you're still locked in that gear. And if you want to go a bit quicker, you can. So what happens with electric is you've got far better control. So the operator flat to the floor, that will all fall away. And the motors are much more sophisticated. So you can do, plus or minus 1 RPM. You can dial up speed very precisely with an electric motor. So we'll see definitely a change in operator behaviour. The other thing, while we're on the topic, electric is a hell of a lot easier to automate. So you'll make an electric truck autonomous or driverless a lot easier than you will diesel. And we're doing that. We expect to have something out to the market in the first quarter of next year. And that will be a game changer for industry to go electric and driverless, and then we can start to remove people out of the pit.
No, definitely. There's lots of. It's good to hear your story because it's like you said earlier, it seemed like it's been just a huge challenge from the likes of Cat and Komatsu or whoever else that you just can't do it. So it's good to see someone like yourself come and do it in 6 months or whatever. Just going back through, and I saw a question around how your truck compares to the Fortescue Livio truck. I think that was a much bigger truck, isn't it?
You called it Europa. You don't mean Europa. You mean
Livio.
The Liber. Oh yes, rightio. That one's called Front Runner. So that Roadrunner. Sorry. So the Roadrunner truck from Fortescue, full battery electric. How do we compare? We get a lot longer run time. So that truck, just goes back to energy density. You just can't chuck enough energy, enough battery capacity onto the truck, and so you're left with running at 2.5 hours. Which good on Twiggy. He's obviously modelled that, and he's accepted that, and he's got his fast charge happening, which is fantastic. And then he's put his money where his mouth is and spent $3.6 billion to order 465 units off Liebherr over the next few years. So that's probably the difference between the Liebherr truck and our truck. Yeah, obviously it's slightly different technology. It's got AC electric, so it's got wheel motors. We don't have wheel motors, we have a diff. That's probably the main difference. Yeah, runtime. Yep.
Okay. One other question that's just come through on everyone's saying like great work and all that, but do you see a world where a larger fleet of smaller autonomous trucks could replace a smaller fleet of larger trucks, which I know plays into, I suppose, the space you're sort of playing in electrifying? Yeah. Curious in your thoughts on that one.
Yeah, so we have a client. Interestingly, they have small trucks at one site and big trucks at the other. Now, I said to the fleet manager, Jake, his name is, I said, Jake, what's the go here, mate? And he says, Clayton, someone in the 90s, late 90s, just wrote a 2-pager and it said big is better. So we bought bigger trucks. He said, but when he looks at it, he says he'd rather the smaller truck. They're in a Jarrah forest, so the smaller truck gives you a smaller width haul road, so it's less impact environmentally. He said, but on top of that, it's easier to maintain the smaller trucks. And he says, parts are a lot more readily available. He says, when I want to move it from one mine to the other, it's easy to put it on a float and send it. I don't need police escort for the smaller trucks. I can just get my permits and just have my own escort and away I go. He says there's no advantage to the larger trucks in his application. So he would rather go smaller. And then I guess if you look at the bigger miners in town, so the iron ore, so another client, he would move from the bigger truck to the smaller truck. The only reason he's in the bigger trucks is that you don't have as many drivers when you go driverless. But my view is that autonomous trucks will be a lot easier. The electric trucks will be a lot easier to convert and make autonomous. So really, the silver bullet here is full battery electric and autonomous. And if it's a small truck, they're probably better off. The reasoning to go to the bigger truck probably falls away. But I'd love to hear from, I hear from my clients, but I'd love to hear from mining engineers that have got their view on small versus large. But that's what I'm not a mining engineer, I'm electrical, so that's what they do tell me. Yeah.
Just to, another one come through, like you might have mentioned, but like who is looking at piloting these trucks? Or are you able to tell us, apart from your sand mine, where you're going to be sending trucks for trials?
Sorry, Brett, just say that question again.
Question around like where your trucks are being piloted now. Like you've got the one where you're trialing at the sand mine. Yep. Where else were you looking at sending them? If you can tell us.
Yeah, I can tell you. So the sand mine was us doing our performance testing on our electric powertrain and also demonstrating it to the miners. So now we'll have we're going to do one larger truck, a 150 tonne, that will go into an iron ore mine. That 777, that 100-tonne truck, that will also go into an iron ore mine. We'll put one into a gold mine, a very deep gold mine. We'll put one into a shallow mine, so an alumina mine in the southwest. So that's those trials, or they'll be actually in production. They won't be running as trial trucks. They'll be full production trucks, and need to move dirt or have the water cart duty. Yeah, they'll that's where we'll do our endurance testing. Yep.
If anyone else got any last questions, or might just about wrap it up. There's been covered plenty of ground though. So thanks Clayton, and thanks everyone for your good questions. Anyone else? Sure you're about to share those the slides you ran through, be able to share them, Clayton?
Yeah, certainly.
No
I can share them. And look, follow us on LinkedIn. You'll see more come out in the next little while. And then also we're on YouTube. You can watch that video and many others on YouTube just to learn a bit more.
Yeah, I'm sure there's going to be lots happening in the next year or two. You know, it's going to quickly, fast sort of evolving space. So I'm sure there'll be lots happening. But
Yes.
yeah, no, thanks for your prezo and all that, and yeah, much appreciated. And
Thanks, Brett, and thanks very
good luck with
much for
everything.
all the comments that have come through. I've seen them come up as we've been talking. Really appreciate it. Yep.
Yeah, lots of you know, supporting comments to what you're doing there, Clayton. So yeah, great to hear.
And a very good good questions. It's a very good audience, this one, Brett. Yeah, you know, they know their topic. Yep.
No, good to hear. Well, thank you. I'll leave you to your day, and
All right.
thank you, everyone.
Thanks very much. Okay. See you.